What if our interstellar dreams meet an unforgiving truth? What if we never leave the solar system? Not because we lack imagination, but because reality refuses. Our intuition fails at light-year scales. Proxima Centauri is only next door by galactic standards, yet 4.24 light-years is 40 trillion kilometers. At airplane speeds, that's millions of years. At probe speeds, it's tens of millennia. The night sky hides a desert of distance. Even our fastest emissaries, Voyager, New Horizons, would need tens of thousands of years to reach the nearest stars. At 1% of light speed, the trip still takes centuries. Time itself becomes a mission risk. Distance demands velocity. Velocity demands energy. The rocket equation punishes every kilogram you want to push faster. Propellant multiplies on itself. The vehicle becomes a tank carrying tanks, then still not fast enough. Chemical rockets are magnificent and far too slow. Nuclear thermal helps, but not nearly enough. Fusion could change the game, but demands power we cannot yet harness in space. Antimatter sounds perfect until you count the energy to make and store it. Waste heat alone becomes a wall. Beamed sails promise momentum without propellant. But you need a power plant the size of a nation and optics spanning kilometers, aimed across light years. And once you arrive, how do you slow down without the same colossal infrastructure waiting for you? Space between stars is not empty. At a few percent of light speed, a grain of dust hits like artillery. Shields must be thick, angled, and sacrificial. But every centimeter of armor slows you down and demands more energy you do not have. Over decades, erosion sandblasts the hull. Micrometeoroids chip away at optics, radiators, sails. The vehicle must be a flying refinery and shipyard, self-repairing, self-sufficient, and heavier for it. Then radiation. Cosmic rays slice through cells and circuits. We can bury crews behind water, regolith, or magnets, but mass is penalty, and magnetic shielding is power-hungry and unproven at scale. Biology adds fragility. Years in microgravity weaken bones and hearts. Reproduction beyond Earth is an open question. A closed-loop ecosystem must never fail. Food, air, microbes, mood across generations. Civilization must carry the cost. Multi-century missions outlive budgets, borders, and priorities. Risk compounds. Opportunity cost grows. Every launch bought today means hospitals, schools, and climate projects deferred. Communication stretches thin. Minutes become hours, then years. Guidance turns into postcards. There is no resupply, no rescue, no patch Tuesday in interstellar space. Only silence and whatever you brought. Rebuttals arrive. Generation ships, cryo-sleep, uploaded minds. Each moves the problem, not the walls. Physics, metabolism, materials, and ethics. Wormholes and warp, elegant math, missing machinery. The real reason we won't leave the solar system soon isn't one barrier. It's stacked constraints: distance, energy, dust, radiation, biology, economics, governance, time, each survivable alone, together, decisive. This is not defeat, it is clarity. We can fill our own backyard with meaning: moons, Mars, asteroids, habitats, telescopes, power. A frontier vast enough for centuries. Master the inner system. Build closed-loop life support that never blinks. Learn to harvest energy and materials at scale. Prove we can thrive for generations without Earth's cradle. Then look outward again. If we ever cross to another star, it will be because we solved 1,000 smaller problems here first. Not with a miracle drive, but with patience and systems that do not break. So the real reason we'll never leave the solar system, at least not soon, is that reality is exacting. And that's fine. There is enough wonder within the sun's reach to occupy us for ages. Notice what we can do now. Build here, learn here. Light the dark with patient work. One world at a time. Begin with home.